Hello students, very good morning. Welcome to Narayana live classes. Today for class 10 students we are going to discuss assignment number 28 on differentiation. Let us start with the first question. Today's assignment actually we are going to deal with logarithmic differentiation. Problems related to logarithmic differentiation. Okay. So whenever we have a function of the kind some 2 power x or 3 power 2x, 5 power minus 1 power minus, actually individual if you have, suppose if you have d by dx of 2 power x, we can simply write it as 2 power x log 2. Easily we can do that. But here we have the functions as a product. See, product of 4 functions as y. If at all you want to apply dy by dx for product, it will become a lengthy process, a tedious process. Instead, both the sides if you apply logarithm, the process becomes simple. So that is the advantage of logarithm here. So for such functions, whenever you have some complicated functions, see powers, whenever you have a power to the power of power, means both the like base as well as power are functions in x. In such a case also, logarithmic differentiation is very useful. Okay, now let us try to see how it is useful for us. Fine, let us see y is equal to this. So if at all you apply log on both the sides, log y is going to be log 2 power x plus log 3 into 3 power 2x plus log 5 power minus x plus log 7 power minus x using product rule of logarithm. So I write it as log 2 power x plus log 3 power 2x plus log 5 power minus x plus log 7 power minus x I can write. Now this is otherwise we can say x log 2 plus 2x log 3 plus of minus x log 5 minus x log 7. I can write this. This is all equal to log y. This is all equal to log y. Whenever you want dy by dx, both the sides if you differentiate with respect to x, we are going to have, see, I'll write it here. So we have log y is equal to x log 2 plus 2x log 3 minus x log 5 minus, see, that is what we have, x log 2 plus 2x log 3 minus x log 5 minus x log 7 minus x log 7. If you apply derivative on both the sides, we are going to have d by dx of 1 by log y, that is 1 by y into dy by dx, chain rule. That is equal to, log 2 is a constant, so log 2 into derivative of x is 1 for us, plus 2 log 3 is a constant, 2 log 3 is a constant, so derivative of x is 1, minus log 5 is a constant, so derivative of x is 1, minus log 7 is a constant, derivative of x is 1. That is what we can write. So here we have dy by dx is equal to, y goes to the other side, means if you transpose it to the other side, it becomes y times of log 2 plus log 2 goes to the power position. So it is log 3 square, that is log 9 minus of log 5 plus log 7 I can write. That is otherwise. What is y for us? Y is nothing but the given function, that is 2 power x into 3 power 2x into 5 power minus x I can write as 5 power x into 7 power minus x I can write as 7 power x. Okay, times of log, here we can apply product rule. Log m plus log n is log mn. So 2 9s are 18. As you have minus here, that becomes divided by, here also product rule, log 5 plus log 7 is log 35. So by 35. So dy by dx value becomes this one. What is that? 2 power x into 3 power 2x by 5 power x into 7 power x log 18 by 35. If you look at the options where we have that, 2 power x 3 power 2x by 5 power x into 7 power x log 18 by 35. This will be the right answer for this question. Okay. Now let us see the next question. d by dx of x power tan x. If you look at the base is x, power tan x. Both are functions in x. Of course, if at all you have d by dx of x power n, it is very simple, n into x power n minus 1 we can write. If at all we have d by dx of a power x, we can write it as a power x log a. It is easy. But here we have d by dx of x power tan x. Base is a function in x as well as its exponent is also a function in x. In these two cases, if base is a function in x, exponent is a constant. Here the base is constant, the exponent is the function in x. Okay, so whenever you have function to the power function, it is always correct to use logarithms. So we have a standard result. What is that? Whenever you have a function f of x and g of x in such a way that dy dx of f of x power g of x, you have to find out dy dx of f of x to the power g of x, that is given by f of x power g of x into f dash of x by f of x into g of x plus log f of x into g dash of x. This is a formula we have in finding derivative of f of x power g of x. Okay, f of x is a base function, g of x is a function in the power position, that is exponential position. So this is what we have to use. Therefore here if you take f of x is x, here f of x is x and g of x is how much? Tan x. Therefore dy dx of here x power tan x is equal to, the formula is x power tan x into f dash of x. F of x is x, its derivative is 1 by f of x is of course x into g of x. What is g of x? G of x is tan x plus log f of x means log x into what is that? G dash of x. What is g dash of x for us? Secant square x. Secant square x. So the answer is what? X power tan x times of tan x by x plus log x into secant square x. See, x power tan x into tan x by x plus log x into secant square x is nothing but first option for us. Okay, so that is the right answer. So this is very important. If you remember this formula, you can solve any of these questions easily. Next, let us see the next question. Given that cos x by 2 into cos x by 4 into cos x by 8 so on is equal to sin x by x, that is the inequality we have given, then the sum of 1 by 2 square secant square x by 2 plus 1 by 2 power 4 secant square x by 4 plus so on is. Okay, so what to do? This is what is given for us. From this, somehow we have to get this function into picture. We have to get this into picture. How? How to do that? For that, I am going to use logarithms again. Both the sides I will apply log. If I apply log on both the sides, I am going to have log cos x by 2 plus log cos x by 4, let me write it as 2 square, plus log cos x by 8, that is x by 2 cube, because here I have 2 square, 2 power 4 like that I have, so let me write like this, plus so on, infinite terms I have, that is equal to log sin x, I can write as log sin x minus log x. It is in the form of log of m by n, log m minus log n. What is the next step? Both the sides differentiate with respect to x. On differentiating both the sides with respect to x. What is derivative of this function? Log x derivative is 1 by x, that is 1 by cos x by 2 into derivative of cos x by 2 minus sin x by 2 into 1 by 2. What is this? Chain rule. Chain rule. Next, here also we get minus 1 by cos x by 2 square into sin x by 2 square into 1 by 2 square. So on. That is going to be 1 by sin x into sin x derivative is cos x minus of course 1 by x. This is what we have. So let us try to write it now. So what do we have now? We have 1 by x square. So if you look at this, this is nothing but 1 by 2 times of minus 1 by 2 times of tan x by 2. Minus 1 by 2 times of tan x by 2. Let us write it. That implies minus 1 by 2 times of tan x by 2 minus, what is the next term? If you look at this, this is minus 1 by 2 square times of tan x by 2 square minus 1 by 2 square times of tan x by 2 square minus so on. That is going to be, what you have? Cos x by sin x, that is cot x minus 1 by x. Cot x minus 1 by x. Again here in this we don't have any like secant square terms, we don't have. How to get them into picture now? Again differentiating with respect to x. Again differentiating both the sides with respect to x. What do you have now? Derivative of this function minus 1 by 2 is a constant and derivative of tan x is secant square x into derivative of x by 2 is 1 by 2. That is chain rule, right? minus here also 1 by 2 square is a constant. Derivative of tan is secant square of x by 2 square into derivative of x by 2 square is 1 by 2 square, chain rule, so on. That is equal to cot x derivative is minus cosecant square x, and minus 1 by x derivative is plus 1 by x is minus 1 by x square, so minus of minus becomes plus. Now if you simplify, you are going to have 1 by 2 secant square x by 2, that is 1 by 2 square because 2 here and 2 here, 1 by 2 square secant square x by 2 plus 1 by 2 power 4 secant square x by 2 square plus so on is going to be cosecant square x minus 1 by x square. Both sides we are multiplying with minus sign. So this is what is expected us. This is what is given in the question. Look at the question. 1 by 2 square secant square x by 2 plus 1 by 2 power 4 secant square x by 4 plus 1 is. So what is the answer we got? Cosecant square x minus 1 by x square. Nothing but first option, that is the right answer. So see how logarithms are useful for us. By applying logarithms on both the sides, the functions have become, I mean to say, the derivative has become a simple task for us. Otherwise, we have infinite number of terms. It is not at all possible to apply derivative there. Derivative of u, v, w, how many you can take? There is no limit for that. So, such questions, application of logarithm is very, very useful for us. Fine. Now let us see the next question. Y is equal to x power sin x plus sin x power x. Then what is dy by dx? So this is a simple question. In this case, we take it as u and it as v. So solution is y is of course u plus v. First we will find out du by dx. Du by dx means derivative of x power sin x. That is x power sin x into, just now we have seen the formula. This is f of x power g of x into f dash of x by f of x into g of x plus log f of x into derivative of g of x, that is cos x. This is the value of du by dx. Then what is dv by dx? dv by dx is the next function, sin x power x. So here f of x is sin x, its power g of x is x here. So f dash of x, that is cos x by f of x sin x into g of x, that is x of course, plus log f of x, that is log sin x, derivative of g of x, that is 1. So if you want dy by dx, dy by dx is simply du by dx plus dv by dx. Simply add up these two. If I add up these two, the answer is over. So what is that? X power sin x into sin x by x, x power sin x into sin x by x plus log x into cos x. Yes, this is that. Next term, sin x power x into x cot x plus log sin x. So definitely the first option is right answer for this question. Okay. So that is the end of this assignment. Thank you. Have a great day.